Okay. All right, so like I said, I'm gonna go over what R is, how to get it, how to install it, what RStudio is, how to get it, how to install it, and then how to play in RStudio. So let's go ahead and do that. I'm gonna share my screen. Okay, so I hope everybody is following along with their own computer. But if not, I'm recording this, so you can always go back and re-look at everything. So R is a statistical programming language. It was built specifically by sociologists because there weren't a whole lot of statistical programming languages that you could use without paying out the nose for them. Specifically, there was one statistical programming language when R was created called S. And S was very expensive. And so a bunch of statisticians and sociologists got together and created R because it's one letter before S, so it was better. But to get R, all you have to do is Google just the letter R, and you'll find the R project for statistical computing. That's what we're gonna look at today. The R project for statistical computing gives you a whole bunch of information just on that homepage, all the different versions, the news on Twitter, how to get help, and where to download. So when we're downloading, for those who do not have R yet, the way to download that is to go to the CRAN. Now, CRAN is the Comprehensive R Archive Network. The CRAN is where every single one of the packages are available, as well as every version of R. I generally pick a mirror that is, so each of these links represent a mirror, a place, a server where R is held, and including all of its packages. I generally pick one that's close to me. So I'm gonna scroll down to US, and see, I generally pick up the one at University of Michigan because University of Michigan's math program is really, really good. So it generally has has all of the up-to-date packages. But the Carnegie Mellon one also is really good at keeping everything up to date. So either one of those work well. I believe many of the other mirrors also work really well. So these are just the ones that I know of that I've tested multiple times and work for me. And then what you're gonna wanna do is you're gonna wanna pick the platform that you have. So if you have a Windows machine, you're gonna click download for Windows. If you have a Mac machine, you're gonna click download for Mac. And if you have a Linux machine, you're gonna click download for Linux. Everybody following along with a laptop or a desktop computer? So I got a yes from Tiff. Okay. Jeff is here. Jeff is installing now. Cool. Excellent. All right. Awesome. All right. So I have I have a Mac, so I would click download for Mac, and I would pick the package, the .pkg, that is the newest because I want the latest and greatest. But I downloaded R last week, and so it's this particular version. So I already have it. So I'm not gonna install it here, but if you click it, it'll automatically download to your machine, and then it'll ask if you want to install it. And for Mac, you just move it from its folder, like just move it to the applications folder, like you do with most things that you download for Mac. For Windows, it should just start installing, and get you through the install instructions. Just keep clicking next. Now for the Windows version, you're not going to want to install the 32-bit unless you have a 32-bit machine. I'm assuming everybody probably has a 64-bit machine now because it's kind of hard to find a 32-bit machine now. Awesome. So if everybody has a 64-bit machine and it's Windows, make sure you install the 64-bit version, and you don't need the 32-bit version. It usually gives you the option to put both. Okay, so once you've installed R, now R will work just fine on its own. So we can go into my applications here and look for R. So this is what R looks like all by itself. See, it gives you what the version is, and see, I have the brand new version. There we go. The 3.6.3 from February 29th. And it gives me all of this information, but it basically just gives you a console. And it's pretty lackluster. I can create new okay, I can create new a new document where I can put code and save it. But again, regular R is pretty lackluster. You can do everything in regular R that we're going to do in RStudio. RStudio just is a bit easier to work with. So I'm going to do that. I'm going to talk about that now. Get out of R. Don't save the workspace. I don't care. Okay. So RStudio is an IDE for R, an integrated development environment. It is also open source. So R and RStudio are free. They're both open source, and that's why we can download them all for free. And them being open source is really good because that means lots of people in the community keep contributing to both R and RStudio to make it better, which is pretty amazing. There are packages in R to basically do anything because there's a whole package in R that helps you figure out how to create a package. I created an R package back in grad school called ant track lib to track ants through videos. And we're not going to talk about that, but it's not super hard to create your own R library. And so people have created R libraries to do pretty much anything. So for RStudio, we're going to go to products and look for RStudio. And we're going to go get RStudio for desktop. And everybody wants the free one. Now, you can also install RStudio from Anaconda, from Anaconda Navigator if you have Anaconda. But since I'm teaching specifically Introduction to R today, I am assuming you don't have Anaconda. So this week I'm doing Introduction to R. Next week I'm doing Introduction to Shiny, which is a package in R. And then the week after that, I'm doing Introduction to Python and Anaconda. And then the week after that, I'm going to do basic data analysis with Anaconda. So if you would like more Python help specifically, you'll probably want to skip this week and next week. And then the week after that, I'll be doing a bunch of Python stuff. But if you don't have Anaconda, you're going to want to click Download RStudio Desktop, and you choose your version. We want the free one. And generally, it detects what type of machine you have and gives you just the right one for you. Okay, so once you download RStudio, you're going to install it, and you're going to run through the same type of steps that you did for installing R. Now, for reference, you must install R before you install RStudio. RStudio is just an integrated development environment. It does not install R for you, and it won't work unless you already have R on your computer, which is why we went through the downloading and installing R first. Excellent. For anyone who just joined, I have a few ground rules. I'm asking everyone to keep themselves muted unless they are talking, and feel free to interrupt me with questions. I am happy to take questions, and any question that you might have, other people probably have too, so please don't feel embarrassed to ask questions. And I'm happy to answer them also anonymously, so if you want to send me a private message asking a question, I'm happy to answer the question out loud without saying who asked the question. And then the second rule is that everyone here knows me from a different place. And even though I'm pretty upfront about myself, some people here would like to be more compartmentalized with their lives. So please respect that and don't ask people how they know me. Or send like private messages to people asking those questions. If they want you to know that information, they will tell you. I'm also recording this class, so anyone here who is not happy about that, please let me know. Okay. So once we've installed RStudio, then want to go and open it. Okay, so when you install RStudio for the first time and you open it, and this is what it looks like. It'll generally list your files here on this bottom right. In the top right, you'll have your environment, which should be empty. And on the left, you have this big long screen. At the very top, it says console. Everybody with me so far who is following along on a computer? Feel free to use the reaction thumbs up if you don't want to say so out loud. Cool. Excellent. Jeff, how about you? Okay, cool. So Jeff, have you got it all installed and everything, and you have RStudio open? Excellent. Okay, cool. Well, let me give you a kind of a tour of RStudio. So we've got this whole screen that's our console. Now the console is where you can just run code immediately. So R can be a glorified calculator. And can do any type of calculation in the console. But R can be so many more things. So in the console, basically you can run any code and immediately have results. It also means you can immediately know if your code is wrong. However, it doesn't save. So if you run your code in the console, you've got nothing. Or you have nothing to show for it. However, you can go up here to this little plus button at the top, in the top left, and open a brand new R script or an R notebook. I happen to very much like R notebooks, but we're going to start with an R script since it's simpler. So this looks a lot like the R script file or the brand new file that I opened when I opened regular R, right? It's just an empty file, and you can type in code, and then you can save it. I'm gonna say empty file. If you use a hashtag is a comment, so it's code that won't ever get run. So I use a lot of comments to help me remember what it was I was trying to do code-wise. Also to help me organize my code. If I want to set forth a piece of code to do something particular, I will use comments to write all the different steps and then do each one. Oh, excellent. Thank you, Glenn. So apparently for Linux users, R is basically already installed, and you may need to only install RStudio. Very cool. I didn't know that. So I'm going to save this as empty file, or save this empty file by clicking the little save button. And to do that, you basically type the name of a file, and it's a .r. All of the files in R, specifically just R code files, are files that R will recognize, both R and RStudio, that you can open and then just run. So we could hit the run button here, and it does nothing because all I put in there was a comment. Does that make sense for everybody? Excellent. Okay, so R can be a glorified calculator. R can also do all kinds of awesome things. And so we're going to talk a little bit about what R can do. One of the things we're going to do is we're going to install a package. So R has a million different packages, which are really good for lots of different things. One of the packages that comes basic, or that comes in R already installed and loaded, is the datasets package. So what I'm going to do is I'm going to type in question mark datasets.package, or datasets-package. Now in RStudio, the reason I really like this IDE is it does a lot of automatic fill-in for you. If you start typing in the name of a variable, it will automatically find it for you. If you start typing in the name of a package that's already installed, it will look for it for you. It will help you autocomplete. And if you type in question mark, you get to the documentation for R, which is fabulous. So I'm going to type in question mark datasets, because datasets is a package in R that contains a shit ton of data. So when you type in that question mark, you get your documentation here. And I'm going to click on this index, because that gives me everything that's in the datasets package. It's just the index of the datasets package. So you can see there are a bunch of different datasets. So there's a ability.cov, which is an ability and intelligence tests. There's air miles, which is passenger air miles on commercial US airlines from 1937 to 1960. Air passengers, air quality, ANSCOM, and that's just the A's. So there are data sets basically for every single letter. This package only has data sets in it. And all of these data sets are already in your environment. You just have to ask for them. So I'm just going to type in quakes. And you can see quakes is that location of earthquakes off of Fiji. All I had to do was type in that name, quakes, and it gives me all of this information. This is great for being able to play with data and to create all kinds of analysis without having your own data first. Again, one of the things about R is that it'll automatically only show you a certain number of rows. It only shows you the first 200 if you ask for it to show you the entirety of a data set. And already, look, that's already like taking up, I have to scroll through a bunch. Okay, so that's one of the base packages in R. There are a bunch of base packages that are already available, like graphics, methods, stats, utils, which makes sense. These are all packages that are already loaded. Now you can see that they're loaded because they have the little check mark by them in that packages tab in RStudio. If we wanted to load one of these other packages that are listed in the systems library, all we have to do is click that little check mark beside it. Now, when we do that, let's load crayon, for example, it automatically creates this, this function call, library, crayon, and points to the location for your package. Now, generally, all you have to do to load a package is you can either hit that check mark or you can just type in library, open parentheses, and then put in the name of the library you want to pull in. It's already saying, okay, these are a bunch of libraries you could pull in. Do you want to pick one of these? Now that's loading the library you already have. The next thing I'm going to do is talk about how to install a library you don't have. So to do that, you can do one of two things. You can click on this install button, and then it asks you for the names of the packages, and you're going to separate them with spaces or commas. Or, and you're going to want to check this install dependencies bit. Or you could type in install.packages and put the name of the package that you want to install in quotes. Now, I'm going to ask you to install a specific package called swirl. And again, RStudio is going to do all kinds of nice autocomplete for you. And if you hit install, it gives you that install.packages of swirl. Right there. Do I still have everybody? Glenn, Jeff, we good? So yes and no. So for Python and for R, single quotes and double quotes don't matter. They both mean the same thing. It's just that you want to use the same one at the beginning as you use at the end. And sometimes you need to put in commands that have quotes in them or strings that have apostrophes in them. And if you have a string that has an apostrophe in it, you're obviously going to want to use the double quotes. No worries at all. That's a really good question, and I get it every single class. So thank you for asking it. All right, so we've installed the package Swirl. So the next thing we need to do is we need to load it. Now, again, we can do that one of two ways. We can go find it in our list of packages and click the check mark. Or we can type in library swirl in our console here. I'm going to click the check mark. Now you can see that you get a bunch of text at the beginning when you load in Swirl. It says, hi, type swirl, open close parentheses when you're ready to begin. Attaching the package Swirl, the following object is masked from the package crayon, reset. So what this last sentence means is that there is a command in the package crayon called reset that R is now saying, okay, well, we're going to instead use the reset in Swirl because there's also a function in Swirl called reset. Does that make sense? Actually, no, that shouldn't make sense at all because I didn't even talk about what functions are. So we've already actually used two functions. We've used the install.packages function and the library function. Function in R and in any other programming language is simply a set of code that takes in 0 or more inputs and gives you 0 or more outputs. For example, library takes in at least one input, like the number or like the name of the package, like Swirl, and potentially the location of where it's installed in your machine. And then and then loads it into your workspace. Now it doesn't give you an output, it doesn't give you a variable, but it simply installs stuff, or not installs, it loads stuff. There are many, many, many different functions in R, and we can also create our own functions in R because R is a functional programming language. Now, generally, sorry, was there a question? Okay. Generally, there are two different types of programming languages. There is functional programming and object-oriented programming. There are now some programming languages that are kind of a mix of both, but the main difference between functional programming languages and object-oriented programming languages is that in a functional programming language, to get any new variables, you need to call a function. Or you have to create the variable yourself. But variables do not inherently have functions built into them. On the contrary, an object-oriented programming language will have objects, and each object inherently has methods built into it, which are functions, and aspects of each object, which are other pieces of information about the object. So each object can then instantiate many different variables. So Python is an object-oriented programming language. And so in 2 weeks, I'm going to do some introduction to Python stuff if you want to tune in for that. But today we're going over R, and R is a functional programming language. So all of our variables in R only have the one value for them, and to get anything extra from them, you have to call a function. Does that make sense? Okay. Good. Okay. So let's go ahead and start running the package swirl. So the instructions gave us type swirl, open, close parentheses when we're ready to begin. So let's go ahead and do that. And the first thing you get is a bunch of text asking you to sign in. So make sure you give yourself a unique name, because every time you call swirl, it's going to call the file that has your name, because it saves your progress. Now, the reason we installed swirl is because swirl is a way to learn R in R. It is an interactive lab type package. It will ask you questions and expect you to code, and will tell you when you do it wrong. So I'm going to type in red. I have typed in red before, but I never got past this very beginning. So it didn't have anything saved for me yet. So the first thing it does is gives you a bunch of housekeeping. The ... is your cue to press enter. So that's what we'll do. Also, when you see answer, the R prompt, which is that less than sign, or greater than sign. Or when you're asked to select from a list, that means it's time to put a response in. So for now, we could select 1, 2, or 3. All 3 would get us to the right place, because all 3 of them are the same, are basically the same answer. But we're going to select 3, or I'm going to select 3. Now, you can exit swirl and return to regular R at any time by pressing escape. And if you're already at the prompt, you can type bye with open close parentheses to exit. Now, you see how we typed in swirl open close parentheses, and bye also is an open close parentheses here. These two things are functions. The way we distinguish a function in R from a variable is we use open and open close parentheses. So the parentheses, inside the parentheses, are where we would put our inputs if we had inputs. If you type in the name of a function without putting in open and close parentheses, it just gives you a bunch of information about that function. It will not actually run it. So you know if you type in the name of a function and you get a bunch of printout on your console, that means you forgot the open close parentheses. Now, if you type bye or the escape key, it will generally save your progress. But bye will definitely save it and will give you a message telling you so. It's saved my progress before without me typing bye, so I think it does it anyway. So now when we're at the R prompt, we can type skip to skip the current question. You can type play to experiment with R on your own. And then until you type NXT, you can play until you type in NXT. Bye exits and saves your progress. Main returns to Swirl's main menu, and info displays all the options again. Now, if you look at this, this is all in my console, and I can scroll back up to everything that we have done today. So everything you've done in the particular instance of R Studio that you've opened is all saved in the console just for that day. So if I closed out R Studio and opened it up again, my console would be empty and I wouldn't have any of this information. Now this is another really important point. If you create variables in R or in R Studio and you do not save your workspace, when you open up R Studio again, those variables will be gone. So when you go to exit R Studio, it's going to ask you if you want to save your workspace. Now, if you do want to save your workspace, say yes, and it will save your workspace to a .rmd file. And then, or no, I'm sorry, to an RData file. And then when you go back to open up your R Studio, your workspace will still be there. It will show up right here in this global environment section. All right, so we've got this ... which is our cue to hit enter. So let's go ahead and do that. So now we've got a list of courses. So there are a lot of different courses in Swirl. Each of the first 4 here are ones that are built into Swirl already. You don't have to worry about installing anything. You just have to pick one. And it will automatically pull in for you. However, many people have also created a bunch of other courses in Swirl, including a network analysis package or a network analysis course that I created that is part of the Swirl GitHub. So all you have to do is to be able to find all of the ones that are available, you can go to GitHub, Swirl courses, and you can see all the different options. Let's go ahead and do that. So there's a bunch. We can look at all the branches. We can look at the pull requests. We can also go to the Swirl Stats website here and see everything available. Now, if you wanted like a Swirl course that wasn't here in Swirl, or it wasn't here available via Swirl Stats, via their GitHub repository, or you were taking a class and your instructor gave you a Swirl, you could load any other Swirl into Swirl and use it as an interactive lab. So for example, if you were taking my network analysis class, I'd give you my network analysis swirl and ask you to work on it. And then you'd be able to install that and answer all of the questions via RStudio. But we're going to start with introduction to programming in R. But again, there are lots and lots of different things here in Swirl. There's even a whole nother library called Swirlify that you can create your own swirls in. Okay, but I'm gonna go ahead and start with R programming, the basics of programming in R. Now, I could choose that particular course. I could go to the Swirl course repository, go back to the Swirl course repository, or I could type in 0 to exit Swirl. So I'm going to go through the first couple of questions in the R programming course, and then we'll go back to playing around just in the R console. So we've selected that R programming course, and now you can see there are 15 modules, all the way from basic building blocks to base graphics. And this is just in base R. This does not include loading any packages at all. So R is extremely useful for lots of different things. All right, so I'm gonna go ahead and click on or select the first module here, the basic building blocks. Oh, wait, before I do that, are there any questions? Anybody? Awesome. Okay. Well, please feel free to interrupt with questions at any time. And when I say interrupt, please feel free to unmute yourself and just ask them out loud, or send me a private message if you want to send me a private message, or post to everyone. Okay. All right. Well, it looks like everybody's doing pretty good so far. Let's go ahead and do the first couple of questions in the basic building blocks module, and then we'll go back to regular R and people can just ask questions. Okay, so in this lesson, we will explore some basic building blocks of the R programming language. And remember that ... means hit enter. If at any point you'd like some more information on a particular topic, you can always type help.start at the prompt, which will open a menu of resources, either within RStudio or your default web browser, depending on your setup. Alternatively, a simple web search often yields the answer you're looking for. The documentation for R is amazing. Googling basically anything you want to do plus the capital letter R will get you to the package that you want, or a plethora of packages. I spend a shit ton of time in Stack Overflow, which is basically a website where people to post programming questions and other people to answer them. Kind of like Reddit, but for programming. And then answers are like voted up if they're good. So Stack Overflow is pretty awesome. But also the documentation in R is also pretty great. So again, if you type in that question mark, And then basically any word, like the name of a package, the name of a function, and RStudio will look for it in the documentation. Now, if you don't know the name of a package or the name of a function that you want, you can always type in 2 question marks and just a word, and it will search all the documentation for that word. Now that may give you a shit ton of stuff. So we have a new person who just added. So I'm gonna go over the rules one more time. So I have some basic rules, which are I'm asking everybody to be muted until they have a question. And then everybody here knows me from a bunch of different places. And while I'm super out about all of the things, not everybody is. So I ask that people respect that and not ask questions about where people know me from. If those people want you to know where all about their lives, they will tell you. And finally, I'm recording this, so if you are not here to be recorded, I understand, but I'm recording it so I can post it on YouTube and let other people take this course because they weren't able to do that today from 12 to 2. So right now we are going through the package swirl in R. We're looking at the very first lesson inside the basic coding in R course. And then after we go through the first couple of questions, I'm just going to take questions and we're just going to code on the fly. Now, coding on the fly can be quite dangerous, but we're going to risk it. Like I said earlier, feel free to interrupt me with questions, either via voice or typing them as a message to everyone or typing them as a private message. If it's a private message, I will read the question and answer the question, but it will not say who asked it. Because I feel like everybody will want to know the answers to those questions, even if the person doesn't want to say who they are, and that's totally cool. Okay. So, in its simplest form, R can be used as an interactive calculator, which we've already talked about a little bit. Type 5 plus 7 and press enter. So, let's see what happens when I don't do it right. So swirl says that it's not exactly what I'm looking for. Try again or type info for more options. And then repeats the question, type 5 plus 7 and press enter. Let's see what happens when I get it right. You are doing so well. Swirl is so nice. R simply prints the result of 12 by default. However, R is a programming language, and often the reason we use a programming language as opposed to a calculator is to automate some process or avoid unnecessary repetition. Now, anyone who's ever taken any programming class, that's generally what we use programming languages for. We generally do not use programming languages to be a glorified calculator. But sometimes when you're in R, you need to calculate something real quick. You can use it that way. Now, in this case, we may want to use our results in a second calculation. So instead of just typing 5 plus 7, we can create a new variable. So if we just typed in that 5 plus 7, all we did was display 12. That's it. It didn't save it. If you look inside your environment here, it's still empty. My global environment still says environment is empty. And anytime we create a new variable, it's going to show up in our environment. So the way we assign a value to a variable is using the assignment operator, which is a less than symbol followed by the minus sign. Now you can do this two ways in R actually. So you can use the less than symbol and a minus sign to that arrow, right? Or we can use an equal sign. They both work just fine. Now Swirl is looking for this less than sign with a minus. So if you type in the equal sign, it's not going to recognize that as the correct answer. But if we think of that assignment operator as an arrow, you're basically assigning the value on the right side of the arrow to the variable name on the left side of the arrow. So we're going to assign our 5 plus 7 to a variable called x. Now, if I do x equals 5 plus 7, which I know is not what it's looking for, but will give me the same response, it does show up in my environment. See? Under values, it has x, which is the name of my variable, and the value that it has is 12. Now I know it was looking for this. Which will do the same thing. Both work. See, again, I still have that x there and the value 12. We have created a variable in R, y'all. I'm the only one's excited about this? I think everybody wants to be really, really quiet. Okay. Well, it says, what does it tell us? You'll notice that R did not print 12. So whenever we assign data to a variable, we're not going to get a printout. If we wanted to print the results, we could use the print command or the print function, but R automatically assumes that you don't want to see that result immediately. Now, to see it though, you can look straight in your environment and see what you created. Now, we can type in the name of the variable, or we can use the print command and print the name of the, print what the variable has in it. So we could just type in x and hit enter, and it gives us the value. And see, now it asks you a new question where it doesn't give you the exact code to use, but tells you to do something a little bit different than what you did earlier. So it now says store the result of x minus 3 in a new variable called y. Basically, this is how we would do that. But I assume everybody probably figured that out already. And now we can see y in our environment. Now, there are a couple of different types of data in R. One of them is a single value variable, which is what these are. X and Y are specifically single value variables. X has one value and it's 12. Y has one value and it's 9. You can also have vectors and matrices. These are generally called arrays in R, and they can have multiple dimensions. Although in R, we generally use at most 2 dimensions. And what I mean by that is at most, we generally have a matrix, which has rows and columns. Now in R, there's a really nice type of data called a data frame, which for those who use Python at all, the R data frames were what Python's package pandas imitated. Because R data frames have been around for a very long time and pandas is rather new. But our data frames are basically matrices. And when I say a matrix, it's a set of data that has rows and columns. But the data frame has named columns and can have named rows. So you can access each of the rows or the columns individually by name. And we're going to play with that in a little bit. Is there a max number of, I don't, it's basically based, so the question, there was a question, is there a max number of dimensions R can work in? It's basically based on the amount of RAM that you have. It will work pretty well in, well, it definitely works well in rows and columns in 2 dimensions. There are packages that allow you to do tensors, which are 3 dimensions. But generally as humans, we don't think of data in more than 2 dimensions, if that makes sense. And when I say 2 dimensions, I just mean like rows and columns. You can have as many columns as you want and as many rows as you want until you run out of memory. So what I'm going to do is I'm going to type by in here to swirl. So it now says I'm leaving swirl and I can type in swirl with open and close parentheses to resume. So this allows me to go back into swirl to learn and pick up where I left off. I'm not going to do that right now, but you can do that at any point in time and it will remember you. It'll say, hi, can you give me your name? You type your name and then it remembers where you were at. If you want to restart, you generally have to type in a new name. I generally do things like add a number to the end of my name if I want to start again. Okay, so we've talked about loading packages, installing R and RStudio, the different types of data, the fact that R has a bunch of data sets to work in. Oh, let me show you what a data frame looks like. So you remember we had that data quakes that we were playing with? So I'm going to set up a data frame called quake equals quakes. All right, so the quakes data set is already in R, so you can use it no matter what, but I wanted to put it in my environment so I could see it. Now, remember I said that there are different types of data in R. We have values. So our values, our X and Y values here are single value variables, but Quake is now a data frame. And it's under the data heading here in our environment. So you can click the little arrow next to Quake and it tells you the names of all the different columns. So we have latitude, longitude, depth, magnitude, and stations. We can also look at all of our data in our data browser by clicking the name of the data frame and it shows up here. Now you can filter here, like you can sort and stuff and you can filter your data, but you cannot edit the data. If you want to edit the data, you have to do it via code in the console. Here, the only thing you can do here is look at it. So like I said, there are a bunch of different data sets built into R. You can do all kinds of playing with data before you even have any data of your own. And which is pretty amazing, because having actual data to play with before you have data is something that most scientists would kill for. Okay, so this is the part of class where I'm just going to take questions. Are there any questions about what R can do? And I'm just going to code on the fly. Again, this is a little dangerous, but I'm going to do it anyway. Nobody has any specific questions? So it depends. So we get the question, is there a special way the data has to be formatted before it can be brought into R? Generally, no. R can pull in data from a bunch of different places, but it does depend on whether it's encoded in a particular way. So you can encode data, specifically UTF-8.
Wait, Simone, Jesus.
And generally that's, Tiff, did you have a question? Okay, so generally you can load in data from R, or load in data into R from anything. You can load it in from Excel, you can load in a CSV, you can download a package from R that will scrape from a website. You can basically load in data into R in any way, shape, or form. R generally works best with UTF-8 formatted data, or binary data, if you're just loading in plain data. So was there a specific data type you were thinking about, Jen?
No, I was just kind of wondering, like, so I see this as, you know, you've got lat, long, depth, magnitude stations, and so I wasn't sure for other types of data. I mean, you know, I work on social networks, and so how would you import a matrix of ones or zeros in a way that R would recognize it?
So I generally would pull it in as a CSV.
Okay.
Or as an Excel spreadsheet. So if you already have it in an Excel spreadsheet, R will definitely will bring in data via Excel spreadsheet. So you can do a read. You can see there are a bunch of different read functions in R. Look, it even pulls in data from Fortran. Read lines is just for text data. Read.csv is generally what I use, but there's also a read.table, which allows you to pull in any type of data, as long as it's in some sort of table. But R will definitely recognize a CSV.
Thanks.
Absolutely. So you can, I got another question. Can you export from R to a graphing program just as you can import data into R? Any particular visual program you know off the top of your head that's easily compatible for that purpose? So I would like to push back on that question. R is amazing at visualization. Why would you want to send it somewhere else? However, R does allow you to export your data. Just type in write. You can write to a CSV file or a table or a socket or a lines. You can write lines, which writes specifically to a text file. So yes, the question is, you can absolutely export your data from R, but R is amazing at visualization. One of my favorite visualization packages in R is called Ggplot. Let's open up Ggplot because Ggplot is the best. Tidyverse is amazing. I love Tidyverse. Tidyverse is a set of packages for R that does a bunch of data wrangling, data manipulation, modeling, and visualization. Tidyverse is wonderful. And it's basically, Tidyverse was created by RStudio. And so they have all these amazing little cheat sheets. So it gives you all the different basics for creating visualizations. Basically, Ggplot, you create the image or the plot space, and then you add things to it. You can add your data, you can add lines, you can add legends. And when I say you add things to it, you just use a plus sign and another function. And it comes out with amazingly fabulous graphics. Let's see. Ta-da! That is just one possible visualization from Ggplot. Ggplot's amazing. But we can also look at the gallery of things from Ggplot. Where's the gallery? What? Our graph gallery. And we can look at all the different types of plots here. We've got histograms. All of these are made in R. So the ones down here are all base R. So you don't have to load in any packages at all whatsoever to make any of these. But everything here is made with Ggplot, and Ggplot is awesome. I happen to be a very big fan of Ggplot. But we can also, let's see, network plot. So for Jen's question earlier, we were talking about networks. So you can use iGraph to do a bunch of fun network plots here. You can also use network D3 to do an interactive version. Very fun. Do some edge bundling, for example. Hi, Day Pretty. Now for each one of these plots, you can click on, like the plot, for example. Tells you about your input data, and it gives you the code. It's magical. I'm going to put the link to the R graph library into the chat so everybody has it. So now you can see all the different possibilities. And any graph that you click on in the R graph library or R graph gallery will give you all the code for creating that graph. Yeah. Are there other questions? Well, while I got here, I could do some basic plotting. Base R uses a plot command, which is a function. You can put in your X coordinates and your Y coordinates, and it will plot dots for you or lines, depending on what you want. I'm gonna say quick, or I'm gonna say depth and magnitude. Okay, so the cool thing about plot is that it will take the names of columns as your inputs, and if you tell it data equals, it knows which data frame to go look at. Oh, wait a minute, did I misspell it? Okay, I guess the plot doesn't work that way. I told you, it's dangerous doing things on the fly. In Ggplot, you can say data equals, and you can just put in the names of the columns. But it looks like base, you can't. But if you start typing in the name of the data frame, you can hit tab and do tab complete. You can also type to access any of the columns in your data frame, you use a $sign. If you type in the $sign and then hit tab, it'll give you a list of all of the data, all of the different columns in your data frame. And while you're inside a function, you can hit tab and it'll tell you all the different parameters that that function might take in. So for example, in base R, when we want to put a title on a plot, main is the parameter we want to use. So do this. And since I'm putting a title, I want to do it as a string. So I'm going to use quotes here. Versus magnitude. Then I can hit tab again and look at all the different other things. So I can tell it what type of plot I want to make. I believe it will generally do a scatter plot, but say I want lines instead. If I want a scatter plot, I would do like a P for points. I think I need an L for lines. Yeah, there we go. And it shows up right here in the plots tab on that bottom right. It's a bunch of lines, depth versus magnitude. Doesn't really give me much information. So I'm just gonna go back to my console and hit the up button. Which will give me the last command that I used. And I can edit it and hit enter. And now I've got a bunch of dots. And you can see that really doesn't look like there's a trend at all in depth versus magnitude. It's just a bunch of random scatter. So it's a base, like a base scatter plot in R. You can add a bunch of things to it. You can change the x-axis label, the y-axis label. You can put colors in. So if we do all the different possibilities. I'm just gonna try it, see if it works. Nope. So I chose color. Color is not a graphical parameter. And this warning message told me so. Maybe COL is. Okay. I got a bunch of warnings. Ah. Oh, sorry. I said CO instead of COL. There we go. COL is a 1, and now I've changed all my dots to red. Like I said, coding on the fly is dangerous. Or coding on the fly in front of an audience is dangerous. But even me, who codes in R a lot, I make mistakes all the time. Most of the time, I just Google it on Stack Overflow if I can't figure it out in the first like 2 minutes. Anybody else have any questions? Ah, the publish function. That is a good question. Thank you. So the publish function, up, where are we seeing the publish function?
It's by the graph.
Okay. Yeah, the Zoom is putting a bunch of stuff on my screen. Okay, cool. So if we click on the publish function, for example, let's do it. And we get this pop-up that says, publishing requires an update of Markdown and a bunch of stuff. Do you want to install these packages now? Sure. I like Markdown. It's gonna update a bunch of stuff and we'll see what happens. Okay, so RPubs is a free service from RStudio for sharing documents on the web. And then RStudio Connect is a server product from RStudio for secure sharing of applications. So basically, like Publish is for people who are publishing to like journals. And so you can publish this to a web document, an HTML document, and share it with people. You can also do that by creating an R notebook. I love R Markdown notebooks. They are my favorite. This is how I share my code with any of my clients. So if I am doing data science consulting work, specifically using R, I'm going to use an R Markdown notebook. And I do that because I can type a bunch of things about what's happening in the notebook, as well as have all of my code and all of my plots all in the same place. I can then publish my R Markdown notebook to an HTML file, and let's just see what it looks like. Can you hit preview? Like this, or at least the base one that you get when you open up a brand new one. Now, we didn't actually run the code, so let's run the code and then do a preview. So once we run all the code in our notebook, so each of these blocks with the gray are code blocks. We run each one, the output shows up in our notebook. So generally I use our notebooks all the time. I put all of my explanation of everything I figured out about the data in a paragraph form, and then put all of the code that I use to analyze the data in code blocks. And each block does like one specific task for me. And then run each one of them so that I can see all kinds of visualizations and statistics that I calculated, and then publish it to an HTML file so that I can then send to clients. Excellent question, though. I'm a big fan of just clicking it and see what happens. Or I would say doing that within like RStudio or in Jupyter Notebooks or whatever. I would not say to do that for a link that comes in from email. Are there any other questions? What are jobs? Where are we seeing jobs?
It's the third tab behind console, the bottom left. It says console, terminal, and jobs. And it says no jobs are currently running.
I do not have a jobs. But for you, that would be any of the code that you are running. If you try to run, like, for example, a .r file, if it takes a while to run, in the jobs tab, it's going to tell you all the different pieces of code that are running currently and taking up your space. Also, if you're running code or code is continued to run, you generally will not get a blinking cursor here in your console, because RStudio will basically only run things one at a time. Now, when I say one at a time, RStudio runs things real fast, generally. But sometimes you have real big jobs that take a while. And so jobs basically will tell you all the different things that are currently running and what's taking up your memory and, and that sort of thing. I don't have that tab because I think I have an older version of RStudio, but I reinstalled R lately. I just didn't reinstall RStudio. Okay, well, if there are no other questions, I'm gonna end class for today. So speak now, forever hold your peace, or at least until next week.
You mentioned that you had a schedule for what you're going to do in the future.
Mm-hmm.
Do you want to put that in the chat or something like that so you know when to pop back in?
Absolutely. So it's going to be every Friday from 12 to 2 is the general time slot. And so next Friday, I'm doing Introduction to Shiny. And Shiny is a package in R. So that's next Friday. In 2 weeks, Intro to Anaconda and Python. Jupyter Notebooks. And then in 3 weeks, Intro to Data Analysis. In Python. Glenn, good question. Where should we be able to download a video? I am going to try. Okay, so I've never actually recorded a video with Zoom before. And so this is just as much an experiment for me as it is for you, but it's been recorded. So I'm going to see about posting it on YouTube. And that's a question that I can't answer. Is anyone else using R with UiPath? You didn't. But yeah, I'm gonna try to upload the video to YouTube. So we'll see. I'll let everybody know. So in 2 weeks, I'm going to start with Python stuff. So that's object-oriented programming for anyone who is asking about object-oriented programming. But I don't think anyone was using R with UiPath. Is anybody using R with UiPath? Everybody's quiet, so I assume that would be a no. Okay, well, thank you everyone for tuning in. And as soon as I figure out where the video went and where I'm gonna put it, I'll let you know. I'll probably post the link on Facebook and any of the other places that I posted, because I posted this class in like 7 different places. So yeah, thanks everyone. Bye.
Thanks, Red.
Thank you.
Thank you.